Hi, this is a video for APE 11 quiz. Okay, let's get started. So first I'm going to go to my APE quiz that can be found on Moodle. And the next thing I'm going to want to do is make sure I pull up the Gene Bank website because the first two questions for this quiz refer to Gene Bank records. So since we're looking at question one, the first thing that I'm going to do, I'm going to go in and Google, no, not Google, on the Gene Bank website, I'm going to look up this ascension number that's located right here because that'll tell me more information about this particular gene. So I'm just going to copy it and look it up. And as you can see, this is the home page for the Gene Bank site. Okay, so it takes me to the particular reference page that relates to this particular gene, and it tells us some basic information about the gene. So it tells us the location, if it's RNA, and it's linear, how many base pairs is located within this gene, and the source of this gene is from a human, Homo sapien. So I'm just going to go and select that for our first choice on the quiz. And the next question is, how many exons does gene Y have? And you can find this information at the bottom of the quiz, gene bank information page about this particular gene. So I see one exon, two exons, and if I just continue to scroll down, I should find more. Three exons, four, five, six, seven, eight, nine, 10, 11, 12, 13, and it appears that this gene has 13 exons located within it. Okay, well that was for the first two questions, and I am now at question three. And question three deals with identifying a gene. So what I'm going to do for this particular gene, I am going to put this gene in BLAST and see what comes up. I'm just going to do the wild type. The wild type is, well, what I'm in, well, I could do the mutant, but we'll just do the wild type since we want to identify it. Yeah. So I'm just waiting on BLAST, and hopefully I will get a result from BLAST from putting this sequence into BLAST. And for the remainder of this quiz, we're going to use this set of sequences. Okay, so I was able to get some information from BLAST, and it appears that this specific sequence belongs to a yeast strand. So I'm just going to go and choose yeast strand. And I'm going to hopefully get some more information about gene S, how many proteins it encodes from this particular, if I click on the description. If not, I could possibly just go ahead and run it within APE, and APE will definitely give me an answer. So it looks like this information is probably not going to be useful from BLAST to figure out how many genes it has. So the protein number of proteins that it can code for. So what I'm going to do, I'm just going to go to APE and open up that software. Just waiting for my APE to open up. Okay, now that my APE is open up, I'm going to go ahead and use the wild type sequence, and hopefully it'll give me the information that I'm looking for. So I'm just going to gene S sequence. Oh, here's my gene S sequence. Okay. So I don't even have to just copy it. Uh-oh. S sequence. Okay, I'm just trying to extract these files. Yeah, yes, extract. I'm just in the process of extracting the files. So let me see if my files were extracted, or if not, I'm pretty sure I can just copy them from this APE quiz. So I'm just going to go ahead and copy it from the actual quiz, since my computer is not letting me open the software, to extract the files, but the files are exactly the same. So, well, the sequencing within the files are the same. So I'm just going to paste that into APE, and I'm going to look and see what the next question was. So it wants to know how many amino acids are encoded with this particular gene. So what I'm going to do, I'm going to translate this sequence, because once I translate it, it'll give me that information. I'm just going to translate it using 3 letters. And I'm going to change this to 50. Press OK. So as you can see, that there are, it's asking about amino acids. So you know, amino acids, which are codons, come in pairs of 3. And as you can see, once I translate it, it says that 562 amino acids are coded for within this particular gene. So I'm just going to choose that for my answer. And the next thing it wants me to do, it wants me to using this set of primers, it wants me to amplify a fragment of the particular gene and see what the size of the gene would be. So I'm just going to go back to that particular gene that I was, the gene S is what we're working with right now. And I'm still working with the wild type. So I'm just going to go in and I'm going to press edit and I'm going to press select from it, a particular area on this gene. So I'm just going to, since this sequence is pretty tiny, I'm just going to select from maybe like 880 to like 1483 because this gene sequence is pretty tiny. And I'm going to see what the size of the, actually, that may not even be necessary to do. So I'm just going to remove that and just go ahead and try to amplify, well, the particular gene using the PCR primers. So what I'm going to do, I'm going to first get a copy of my particular, um, this primer sequence alpha. So, and then I'm going to copy this within the find the DNA, find in DNA sequence. And I'm going to just press paste. Okay, so close it. So we were able to find that, and this appears to be the forward primer. So what I'm going to do is press new feature, and I'm going to press, I'm just going to put forward primer. Then the next thing that I'm going to do, I'm going to just change the color to like pink or something. Okay. Can keep the 4 arrows in, and we just change this with the 10. That's okay. And I'm going to go and do the same thing with the primer beta. Copy it. I'm going to find it, and more than likely this is going to be the reverse. Find it. Paste. Yes, this is very well the reverse, and it's going to be the area from the alpha primer or the forward primer to the reverse primer, and that's going to be our PCR product. So let's just go ahead and since we found that, we're going to press new feature again. This is going to be our reverse, and I'm just going to write reverse. Make sure you check reverse complement, remove the forward errors, and make the width to 15. And press OK. Now, if I want to see how much my PCR product is, I could simply hold on. Sorry about that. I could simply just look for the values that fall in between this particular sequence, and it's from the end of the first primer to the beginning of the second primer. And it appears like the length of this primer is like 956. And on here, it doesn't have an exact value. So what I'm just going to go with, I'm going to go with it being, I'm gonna pull up a graphic map because that may provide me with more information. $146. And I'm just going to plug a few numbers into my calculator really quickly to see if I can get a better estimate, because I think this question is asking based off of an estimate. Okay, so by using those values that were shown in that particular graphic map, I'm going to go with my answer being at 900, roughly 900 base pairs, because when I do the PCR product, it's not giving me an exact value. The value is falling in between 900 and 1000. So it makes it a little tricky, but I'm going to go with the smaller value. So the next question asks, we want to cut the PCR product of gene amplified with the alpha beta. So we're going to use a particular restriction enzyme, STYL, and we want to see how many fragments that particular gene will produce. Okay, so what I'm going to do, I'm going to go back to X this out, and I'm going to go, whoa, just going to that down there, and I'm going to go and highlight all of this PCR product here. Actually, I take that back. Our PCR product is 1,000. It's 1,000. I'm sorry about that. It's 1,000. So what I'm going to do, I'm going to take this highlighted area and I'm going to press the enzyme selector, and I'm going to just find that particular enzyme, and I'm going to press digest. It's saying that it'll cut in 3 spots on this sequence. So, and I'm going to go and pull up how many fragments will be produced. So there's 1, 2, 3. And I'm going to just go and pull up another graphic map to confirm that. Yes, it is 3 spots. And it will contain 3 fragments. So 3 fragments will be produced. And next, we're going to work with our genes. We're going to work with our 2 genes. So what I'm going to do for this particular sequence to find out where the particular mutation falls at with this particular gene, I'm going to go to a mega cluster because I want to align these two genes. And I'm just going to copy them exactly in as they appear because it's going to ask us to see where the mutation is for both the mutant 1 and 2 for our gene. So I'm just going to first copy the first one in because that may take a while. And I'm going to copy the second. Yeah, this is going to take a while since I couldn't, for some reason, get those particular sequence files to abstract, and that can happen on various software. It depends on if you're using a PC or a Mac. Copy, and I'm going to just paste that in, and I'm going to press submit. Oh, okay, that's just based off the name, so I'm just going to go and just call this mutant 1. It'll just say that just because of the names. Now it should do now. Okay. I see exactly where our. So it said so. Apparently, it went from guanine, a guanine to a thymine amino acid. So I'm just gonna go here and see if it has a selection for that. It went from a, where is our particular, okay, so the answer would be B for this one because it's going from a thiamine to a, I mean, a, yeah, a thiamine to a guanine for its amino acid. And as you can see it right here. You have the mutant versus the wild type. And so I'm just going to go back and I'm just going to do the same exact thing for the second mutant for that particular gene. So I'm just going to go back and it's going to give me, tell me the same location. Well, it may not exactly be at the same location, but it's going to tell me a location that it can be found at. Again, I'm just copying the sequence for the second mutant. Okay, and I'm going to press copy. And I'm going to press paste. And I'm going to go and change that name so that error won't pop up when we are trying to align these two sequences. I'm just going to go and check the second one, first one. Okay, everything looks good. So I'm just going to press submit. And I'm waiting for my job to be processed. Okay, so it was processed. Oh, okay, I see it right here. So it appears that it went from A to G. So let's see if that mutation is listed on here. Okay. Um, Computer is trying to freeze up. Okay. And as you can see, you have two different answers that look fairly similar. And it is a spot, the spot is correct, but you want to figure out what it's going, what it was and what it has been changed to. So for this particular question, it's asking really based off of the wild type and the mutant, like to compare the two. So this is the mutant up top, and this is the wild type is at top and the mutant is at the bottom. So the wild type has an A, while the mutant has a G. And I'm going to go back to the quiz. So it appears that letter choice B would be correct based off of the way that I aligned the sequence, comparing it to the wild type versus the mutant. Okay, so now we have to figure out which restriction enzyme can be used. So I'm going to go to nail cutter. And it's going to tell me that information. So it wants to know what enzyme can be used to distinguish the wild type from the mutant. So what I need to do, I just need to find a fragment within this particular sequence that will cut that particular wild type. So I mean that particular mutant. So it's mutant. It's the 1. This is mutant 2. So I'm just going to go back and copy that particular sequence in, and it should give me all of that. I'm going to copy the 2 sequences back into cluster omega because since I didn't save that information. Whoa, okay, whoa. That was not supposed to happen. I'm just going to go and copy that sequence information within. So I'm just going to change the name, just mutant 1. And then I'll be able to take a piece of the sequence and just compare those two to see which one will make for a good choice. I just got to find the mutation again. Oh, there it is. So let's just go back to our question. So we want to distinguish the wild type. So I need to pay close attention to the wild type. I'm just going to copy this whole little sequence here. press to put a new APE just so I can store it so I won't lose that particular sequence. Okay. Mutant. Okay. So I'm just going to copy it. This is for our, I'm just going to put WT for wild type. Okay, that's our wild type information. And I'm just going to open Nab Cutter again so I don't lose that particular information. So on a different page. Oh, oops, Nab Cutter. Nab Cutter. Okay. Okay, and this is just gonna, I'm just gonna put an M for, or I just write mutant out. Let me know that this is the mutant. Versus the mutant. It appears that MSEL would be the, wait, we're between MSL and MS. So that is the mutant. And so it appears that we're going to pick MSLL to be our restriction enzyme that can distinguish the wild type between the mutant based on the comparison of the sequence. If you look right here, it's the wild type. It can be cut with the MSEL, but right here, only the MSLL can cut our mutant. So we're gonna cut our used to cut our wild type. So we're going to just go with MSLL based upon the comparisons between the two, wild type and the mutant. Okay, for our last question, it asks which of these four primers can amplify the PCR product that contains the mutation in mutant one. So what I'm going to do, I'm going to open up a new file. And I'm going to just copy that particular mutant one sequence within it. And it'll tell me which sequence, which set of primers would be a good choice. Okay. Okay, so working with Nutrient 1, I'm just going to go and plug in all of those particular PCR products and primers, and it's going to give me I'm going to look at the graphic map and hopefully be able to figure out which one can be used. No, I don't want to say that. Just gonna X out of that. Okay, so we're just going to go through the same process that we went through for a similar question. Let's just press copy and press paste. So that is a reverse that's in here. That's actually primer Charlie. So I'm just gonna go and call this Charlie. And we're just gonna change it. This is the forward arrow, just change it to 10. It could just be any color because the color is gonna change anyway. So just press OK. And that is Charlie listed in purple. And next we're gonna go to Delta. Just gonna press copy. Excuse me. I'm just gonna press copy. Copy the same exact thing by finding it. And it may be a forward, maybe a reverse. And it is actually a reverse. Yeah, this is a reverse. I'm just gonna press Delta, and this is a double check. Yes, this is a reverse. So I'm gonna remove that forward arrow and change the width to 15. Okay. And next thing I want to do is do elephant and then vacuum, and then we can analyze that graphic map. It's not letting me copy and paste it. Excuse me. Okay, and this is elephant. So we're just gonna go and find elephant. And elephant is a reverse. So let's just go to new feature and put in elephant, and it's a reverse. So it's a reverse. 15. And press OK. Oh, whoa. We don't want the same color. So I just choose blue, different color blue, dark blue. Press OK. And we're going to see vacuum, primer vacuum. Fine. Okay, this is a forward right here. And I'm going to press new feature. And I'm going to call this Falcon. And let's go and find a color for it. It can be yellow or this. Yeah, it can be that yellow color. Just gonna change the width to 10. Okay. So what I'm gonna do now, I'm gonna change this to circular, and I'm gonna see what my graphic mount. So you want a primer. The primer should be going in opposite directions. They should not be going in the same direction or not have a um, coherent. They're like you can't really see the direction or make out the direction. So what I think the primer, best primer to use to amplify this is they are going in the same direction. I feel that it would be best to use primers Charlie and Falcon since they are going in the same direction. Delta and Elephant are going in totally two different directions, and they're not even close to each other. So I would say, and since it's for a PCR product is not that large of a particular product within a sequence, especially for a sequence that is so tiny with only 1,689 base pairs. So the PCR product is going to be small. So the primers used to amplify this should be really, really close to each other and small as it relates to how far they are from each other. And if, as you can see with the Charlie and the Falcon, it's roughly 350 base pairs. They're roughly 350 base pairs away from each other and going in a forward and reverse direction. So that's going to be the primer choice that I would choose for this particular sequence. And this is the finish of APE 11, going through different techniques using APE, blast, nail cutter, omega cluster for APE quiz 11. I hope that this was helpful. Thank you.